Discus athletes tend to be bulky and tall, but height doesn't play a huge role. The sport itself requires athletes to have a strong upper body, but more importantly, have great balance and grip strength. However, height is still an advantage. The average thrower is about 6 foot and 2 inches. For example, former discus throw Olympic champion Robert Harding is 6'7" and 278 pounds. He's a total freak of nature, but his height, size, and technique helped him become a champion. Their long arms allow for an increase in the radius from the axis of rotation, which provides a greater amount of angular momentum. This is from the equation angular momentum equals moment of inertia times omega. With a constant velocity, the moment of inertia increases due to the increase of the radius from the equation moment of inertia equals mass times radius squared. This gives the athlete a greater angular momentum. As well as having a bigger angular momentum, longer arms lead to an increase in torque. This is from the equation torque equals force times radius. Since the perpendicular force applied to the discus will remain constant, an increase in the radius allows for an increase in torque, which ultimately leads to your discus traveling further. Keeping the formula constant, a discus thrower that has a greater mass is able to have a bigger angular momentum from the increase in the moment of inertia given from the additional weight. The second advantage is that a taller thrower can have a higher release point, which can help with the discus trajectory.
As obvious as it is, the equipment used in discus throw is a discus. It is a disc-shaped object that gets more narrow towards the edges. This shape helps to reduce the drag of the disc. The athletes release the discus spinning. This allows for it to be more stable in the air, which helps resist opposing forces that act on the discus. This wedge shape is designed to get lift as wind speed increases. Since drag pushes the back of the disc, its narrow edges allow for the drag to create even more lift. The equipment used in discus throw is different for men and women. They use the same shaped discs, but have different weights. Men's discus weighs 2 kilograms and the women's weighs 1 kilogram. This allows for men and women to throw around the same distance. Besides the weight difference, there are also several types of discus: club, training, top fly, swift, ultimate, target, and rubber. Athletes can decide which discus to use based on their own preference. Club is made of solid wood and meant for all throwers. Training has adjustable weights that allow for beginners to learn discus throw. Top fly, preferably for professionals, is a discus made out of polycarbonate fibers. Swift is a discus designed for workouts that only use 80% of a normal discus weight. Ultimate is just another discus designed for professionals. Target is a training discus that only uses 70% of the normal discus weight. Finally, there's rubber. It's a discus that has rubber edges for grip. Also, throwers typically wear skin-tight suits, similar to those of a track runner. They also wear smooth bottom shoes due to the fact that it's tough to spin with spikes on. Smooth shoes allow for more and faster twirling. Discus throwers throw from a concrete slab, which allows for less friction between the athlete and the ground.
Discus throw starts with an athlete standing in a circle with a 2.5 meter diameter. The athlete then proceeds to spin around and launch the discus. The athlete's body acts as the axis of rotation. Originally, athletes wouldn't spin and just throw the discus. However, they soon realized that spinning enables them to create a larger amount of velocity, which allows for an increase in angular momentum, making the discus travel further. So, in the 1950s, all throwers switched to concrete surfaces and smooth bottom shoes, which allowed for more and faster twirling. During the spin, they keep their arms in where to not only preserve angular momentum by increasing the velocity, but also to reduce the amount of centripetal force acting on the discus. This comes from the equation centripetal force equals mass times velocity squared divided by radius. This means that with a bigger radius, there will be a small acceleration acting on the discus. With careful timing, the athlete re-extends their arms for release in order to reduce the center-seeking force. The distance the discus travels comes from the torque the athlete is able to produce. Again, this is the equation: torque equals force times radius. With a constant force, a larger radius allows for an increase in torque, increasing the distance the discus can travel. The discus far from his body also increases the moment of inertia, which leads to a greater angular momentum with a constant velocity. Once the athlete plants their foot and prepares to throw the discus, the athlete transfers his angular momentum to the discus and releases it. This is known as the power stance that occurs after spinning because it uses the law of conservation of energy to transfer the energy into the discus. Since the angle of release and the speed of the projection are inverses of each other, the athlete tries to release at an angle of around 40 degrees to have a better speed of trajectory.